Okay, so 7.4 is about solving logarithmic equations, or equations that have logarithms in there. You can see at the top says a logarithmic equation contains one or more logarithms. In the first section, the first example, or first couple of examples, we're going to use the definition of a logarithm, and what we mean by that is we're going to rewrite it as exponential, and we'll do that to solve. So on this first one, it's written as a logarithmic equation. We're going to rewrite it as an exponential. So hopefully you remember how to do that. The base number of the log is going to be the base of the power. And then the other side, the 3/2, that's going to be its exponent. 36 to the 3/2 equals x. So what we just did is we got the x out of the log. It's now isolated. It's by itself. So all I need to do is figure out what 36 to the 3/2 is. And we should remember from last chapter, if an exponent is a fraction, that means we're dealing with a root. The denominator is the root, so it's a second root, also called a square root. So I'm going to rewrite this. So it's the square root of 36. And the 3 becomes an exponent. I can actually move the exponent to the outside to make the problem a little bit easier. It doesn't have to go on the 36. So we're going to first take the square root of 36, which is 6. And that's to the third power. 6 to the third power, you can use your calculator if necessary, but that's 216. So that's what x is equal to, 216. Yep.
So what happens to the 2?
So the 2 becomes a second root or square root. We don't have to write it since it's a square root, but that's where it went. So the next one, we're going to do the exact same thing. 8 to the 4/3 is equal to x. So the once again, the exponent is a fraction. The denominator is going to turn into a root. So this time it's a third root of 8, and that's going to be to the 4th power. The third root of 8 is 2. 2 times 2 times 2 is 8. So third root of 8 is 2, and then that's to the 4th power. Well, 2 to the 4th is 16. So x is equal to 16. So if there's just a single log, like those two problems are, if there's just a single log, you can rewrite it as an exponential and solve it that way, remembering the rules we had from last chapter. The next section, you can see here in the box, I've got a property for what we do if there's a log on both sides. Notice it says if log base b of something, I just gave it an m, is equal to log base b of something else, an n. Notice the base numbers are the same, log base b, log base b. If there's a log base b on both sides of the equation, you get to just ignore the log base b's. We know that m has to equal n. So we just get to drop it. And so that's what it says right below this. If the bases match, then the two arguments, that would be the m and the n, we call those arguments, they have to be equal. But underlined here, be sure to check your work for extraneous solutions. We'll talk about that in a moment. But we've got a couple of examples. Log base 2 of something equals log base 2 of something else. We have logs on both sides of the equation. They do have the same base. So the arguments, the x squared minus 4 and the 3x, have to be equal to each other. So I can say that x squared minus 4 is equal to 3x. So I dropped the logs. Now, this particular problem has an x squared in it, which means it's quadratic. This was a chapter 4 type of problem. So it's going back a few chapters. But it's when we factored. So what I did on those type of problems is I brought everything to one side, so it was set equal to 0. So I'm going to bring that 3x over. So I have to subtract it over. I'm going to fit it right in the middle because I want the x squared to be first, and then the x, and then the constant. We call that descending order, where the exponents go from largest to smallest. Now it's set equal to 0, and now I try to factor that. So an x, and we're looking for two numbers which multiply to the last thing, the negative 4, that also add to negative 3. Two numbers that multiply to negative 4 that add to negative 3 are negative 4 and positive 1. Positive 1 times negative 4 is negative 4. Positive 1 plus a negative 4 is negative 3. So we got it factored. And then as soon as it's factored, you're going to take each factor and set it equal to 0. So take x plus 1, set it equal to 0. Take x minus 4, set it equal to 0. Solve both of those. If x plus 1 equals 0, I would subtract 1, and I see that x is negative 1. If x minus 4 equals 0, I would add 4, and I get that x is positive 4. Now here's what I meant above when I said to watch for, or make sure to check your work and check for extraneous solutions. There is a rule that you can only take a log of a positive number. You cannot take a number, raise it to an exponent, and get something negative. So when I go and test these numbers, like plug negative 1 in, for example, plug it into the original, and notice the right side of the equation where it says log base 2 of 3x. If I plug negative 1 in there, that would say log base 2 of negative 3. It is not allowed to take a log of a negative number. So when I plug negative 1 in there, it messes up that side. We can't take log base 2 of negative 3. So therefore, we would say that negative 1 is extraneous. I get to cancel it out. It didn't actually work. When I try 4, plug it in the right side, 3 times 4 is 12. That's a positive number. That's fine. When I plug 4 into the left side, 4 squared is 16. 16 minus 4 is 12. That's also a positive number. That's okay. So x equals 4 is the only one that actually worked. The second one is very similar to that. Log base 4 of something equals log base 4 of something. They both have log base 4s, so I get to drop the logs, and I know then that x squared has to equal negative 6x minus 8. Just like the last problem, I want everything on one side so that it's set equal to 0. But I want the x squared to be positive, so I'm going to move everything to the left side. If I moved x squared to the right side, it would be negative. I don't want that. So that means I want to move 6x, so I would have to add it. And I want to move the negative 8, so I would add it also. So on the left side, I have the x squared. I just added 6x. And I added 8. On the right side, 6x is canceled, 8's canceled, all I'm left with is 0. So now it's set equal to 0, and I try to factor that. I need two numbers that multiply to 8, that also add to 6. That would be 2 and 4. 2 times 4 is 8, and 2 plus 4 is 6. Both positive, so positive 2 and positive 4. So now we set each factor equal to 0. Let x plus 2 equal 0, and let x plus 4 equal 0. In the first one, I get x equals negative 2. In the second one, I get x equals negative 4. Those are my answers as long as they work. I'm going to test them to see if they work. Test negative 2. When we test it on the left side, we always go back to the original equation before we started. The left side says to take log base 4 of x squared. So if you square negative 2, you get positive 4. That's okay. Plug it into the right side. Negative 6 times negative 2, because we're plugging in negative 2. Negative 6 times negative 2 is positive 12. 12 minus 8 is 4, positive 4. So that's okay. Negative 2 worked. Let's check negative 4. When you plug it into the left side, you square negative 4. That gives us positive 16. That's not a problem. Plug negative 4 into the right side. Negative 6 times negative 4, that's positive 24. Subtract 8 from that, we get 16. That's okay. Both of those worked. So I don't have any to cross out. So there could be more than one answer like there is in this case. So that's the end of the notes. From there on, you see below, it says assignment. Those 4 problems, those are your assignment. If you're watching this from afar, if you were at the wrestling tournament or aren't here, this worksheet is saved to the S drive, so you can find it there.